Okay, so this is Robinson annulation reaction, where the first step it is to form an annulate. Then the second step it is to do micro addition. Then after that you make a double bond because you have added time. So the first step we start with the formation of an annulate. An annulate it is different to annulization a little bit because in annulization you find that the oxygen will have a double bond when you have the cation would have the it will be bonded to hydrogen here. So let's do annulate formation. So this is base catalyzed annulate formation. Okay, so we have sodium hydroxide as our base, so we'll just remove this sodium, we remain with the OH. Okay, the OH with a negative charge, right? Okay, so the lone pairs are 6, 1, 2, 3, 3 lone pairs. Okay, so here remember we have a hydrogen that is bonded to a carbon, then a methyl group, right? So this or the hydrogen, the OH, it will attack and get the hydrogen. Okay, when it gets the hydrogen, this bond it will break, sending electrons to this part here. Okay, so the final product, you find that you produce water, which is coming out H2O, and the annulate, cyclic annulate time, because it is cyclic, it is in a cycle form. Okay, so here there's a negative charge, right? And there's a methyl group here. That's the annulate formation. Okay, so how do you know that it is annulate formation? Look at this. When we undergo resonance, you find that this negative charge, the electrons on this carbon, they will tend to go on to initiate a double bond on this part. Then this bond it will break, sending electrons to this oxygen. Okay, so once it sends the electrons there, it will be negatively charged, and with how many lone pairs of electrons? With 3 lone pairs of electrons. Then here there's a double bond, and you have something which look like this. Okay, methyl group is still here. Now look at this. This is known as an in, right? And this one it is the known the oxygen here, the presence of the oxygen, it is OL. Now since there is no hydrogen, it will be we'll add the ATE, so it will be an annulate. Oh yeah, very good, annulate. That's how you form an annulate, right? Okay, so we go to the next step. In the next step, you get this form, right? You undergo the second reaction where you do micro addition reaction. Micro addition reaction. Okay, draw something like this. Okay, we have drawn this. We are adding this compound here, which is alpha beta unsaturated double bond. Okay, so this carbon which is here, that is negatively charged, it will come and attack here to attack and attach. Then the bond which are here, they will break, sending the electrons to this part here. Okay, so you end up forming something which look like this now. Okay, so on combining this, we'll combine this carbon has a negative charge, it will attack and attach. That's how it has done here. It has attached. Then the electrons moved on position 2. So when you are numbering, you number from here first. You count the carbons which are here. So start from here where it was attached. 1, 2, 3, 4. So there are 4, right? So you go also this side. As you are writing this, you are supposed to be counting the point where there is a corner. 1, 2, 3, 4, right? So now the electrons, they are moved on position 2. That's why you have the negative charge. Then on position 3, you have a double bond to oxygen. Okay, that's all. We continue with the reaction. Okay, so the next step, it is to carry out a proton shift. A proton shift, it is more just a process where this the proton that will attach here is supposed to shift to go here. But how can we do that? Yeah, so the first step, it is to let these electrons which are on this position 2 to go and initiate a double bond here. As it is initiating the double bond, this bond, it will break, right? Sending electrons to oxygen will form a negative charge part there. Yes, we form a negative charge. You are seeing, very good. At least you are noticing. Okay, so here there's a methyl group. Then after that, we have now a double bond here. Yes, very good, very good. A double bond here, then a single bond to oxygen with a negative charge. Okay, so here we'll get the water that we started with, the H2O. Just expand it so that we can see how the reactions are happening. So the oxygen with the negative charge, it will come and get the hydrogen. The bond holding this, it will break, sending electrons to oxygen. Once it does that, you end up forming, once you do that, you end up forming an OH2 hydrogen, right? So let's continue like that. But the OH negative, it will go out. Okay, so we are just redrawing everything. Redraw. Okay, OH, the methyl group attached here. 1, 2, 3, 4. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, there's a double bond here. Then we have also an oxygen with a hydrogen. Okay, pardon my drawing. It's not that neat, but it's something good. So the next step we do here, it is a proton shift. This hydrogen which is here to shift to go here where there is a double bond but on this carbon, so that here we initiate the double bond to oxygen. So I write proton shift. Okay, so your proton shift, you form something which look like this. Double bond to oxygen, double bond to oxygen. Okay, so under proton shift, here there is no longer a double bond. The double bond will go on oxygen. Okay, then and on proton shift, you write negative hydrogen ion with positive hydrogen ion. That's all. Okay, we'll continue with the reaction. We are not yet done, but we are about to finish. So on the next step, you just more like expand this terminal carbon here. We are about to undergo aldocyclization, right? So you expand this part so that we do deprotonation. The carbon has 3 hydrogens, so we are going to show 2 hydrogens and extend 1 hydrogen to show the reaction. Then we use the OH that we produce here, the OH, to get the hydrogen. So it will go and get the hydrogen, form water, then this bond it will break, forming a negative charge. So water it will go out here, H2O out, we form water. Then here we end up forming more like a cyclic ring. So just write one, like more like you are about to form a cyclic ring, right? But it's not yet formed. Then you count 1, 2, 3, 4, right? 4 exactly. Also here we have 1, 2, 3, 4. Okay, so on position 3 we have a double bond to oxygen, and here we have a negative charge. On this position we have the double bond to oxygen. That's where we will initiate the double bond to the carbon. Then on this point here we also have a double bond to oxygen. Okay, so this negative charge to come and attack here to initiate a double bond, and the bond here to break, right? Breaking, sending the electrons to oxygen. Okay, so you end up forming a cyclic ring. You end up forming a cyclic ring. So I'll just write it here. The page has finished. Okay, so you have something which looks like this now. Here there is a single bond to oxygen with a negative charge. Then just like that, there's a cyclic ring here, and a methyl group, double bond to oxygen. What else? And also here there's a double bond to oxygen, right? So the position 4 connected with this carbon which is here. Now here we need to use water, since it has a lot of protons to donate. So we use water to donate a proton to this negative charge oxygen. So this negative charge oxygen to get a proton, a tenga proton. Then this bond it will break, making it OH negative, right? Okay, so tikapanga so we are going somewhere. Then the OH to come out like this with a negative charge. What else are we going to make? We are going to make something which looks like this at the end, or something which looks like this. Looks like this. I don't know how to sing, but just that my voice is not okay today. So here we have OH. Here we have the OH, right? Now we have oxygen and oxygen here. These oxygens are highly electronegative, and they will tend to pull electrons to themselves. And as they are pulling these electrons, these hydrogens which are here on this carbon, let me extend them. There are two hydrogens, but I'm going to show one. There will be what? There will be acidic. They are called acidic hydrogens. Now these acidic hydrogens will use the HO negative to get the hydrogen there. So as we are getting the hydrogen, this will only take place in the presence of what? Heat. So as we are getting the hydrogen, the bond to break here, sending electrons to initiate a double bond at this position, then the OH to come out. So only this can take place in where there is heat. So what will come out? Water. will have water, H2O, and this negative OH, negative charge. That's what we are going to have. So after that, we'll end up producing our Robinson annulation. Robinson what? Annulation reaction. Very good. Robinson annulation reaction. So here there's a double bond. Here there's a bond to oxygen. Here there's a methyl group. Don't forget what you have started with. Here there's an oxygen. So that's the primary carboxylic acid. Is it a primary carboxylic acid? No, Robinson annulation. That's a product. Okay. Thank you very much.